Alright, so here it says the table at the right shows how intensity relates to decibels. Also notice how the section here is broken down so that you can see the difference between 40 and 50 decibels. So 1 times 10 to the negative 8th means 40, 2 times 10 to the negative 8th means 42, 5 times 10 to the negative 8th is 45, 7 times 10 to the negative 8th is 47, and 1 times 10 to the negative 7th is 50. Okay, so here it says we have a sound source generating a 0.5 watts of power. What is the intensity of the sound 20 meters away? So we're going to use the formula for intensity, which is equal to the power over 4 pi r squared. So we're going to plug in our power of 0.5 watts, and then 4 pi times 20 squared. Alright, and we get essentially 10e to the negative fifth watts per meter squared. Alright, how many decibels is that using the table? So 10e to the negative fifth, since this is 1 times 10 to the something, we can go ahead and say that is actually 1e to the negative fourth, which would be 80 decibels. Now, if we were to make this, the intensity, say 1,000 times bigger, that would be times 1e to the third, because 1,000 has 3 zeros. Okay, so if we were to make this more intense by a factor of 1,000, 1e to the negative fourth times 1e to the third, we would add our exponents and end up with 1e to the negative 1, which is 110 decibels, which is 30 units greater. Anyway, what is the intensity of the same source 40 meters away? Well, notice that our original distance was 20 and we've doubled it. So you could say, okay, we've doubled our distance, so the intensity should be 1/4 as much. So we can take our original intensity of 1e to the negative 4 and divide that by 4. And we get 2.25 e to the negative fifth, or 2.5 e to the negative fifth watts per meter squared. Or you could go ahead and calculate the whole thing out. 0.5 divided by 4 pi times 40 squared, and we get roughly 2.5 e to the negative fifth watts per meter squared. By what factor would the intensity change if the distance was 4 times as great? Well, if the distance was 4 times greater, then it would be 1/16 of its original. So you could take the 1e to the negative fourth, divide by 16. You get 6.25 e to the negative 6. Now, e to the negative 6 implies that we have 60 decibels as our base. But it's not 1 times e to the negative 6, it's roughly 6 e to the negative 6. So if we had 6 e to the negative 6, that would tell us that it's plus about 6 decibels, so we would have a sound of about 66 decibels.